All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. You're going to have x squared plus 9x plus 14. And then you're going to have x plus 7 and x plus 2. You're going to replace the 2 that you removed at the beginning. And then the first one won't reduce, so you'll have 2x plus 7. And the last one, they both divide by 2 to give you x plus 1. So that would be your answer. For the math knowledge question, an angle with measure sigma is shown in the standard xy coordinate plane, and the angle with measure sigma has the positive x-axis as one side and has the portion of the line y equals x as its other side. What is the value of sine of sigma? So we're basically looking for this angle here. And it says this is y equals x, so that means that this is a 45-degree angle because it splits it in half, and this over here is going to be 45. So we're basically looking for the sine of 45 degrees. But it's not just 45, it's actually 180 plus 45, which would be 225. So the sine of 45 is square root of 2 over 2. But the sine of 225, that puts it into the third quadrant. And so that is going to be negative square root of 2 over 2, which is B. And that's because sine is negative in the third quadrant. All right, so we're looking at lesson 29. So we're going to look at Newton and Leibniz, and then we're going to look at differentials. So hopefully you'll understand the difference between their notations for the derivatives, and you'll understand differentials. Sir Isaac Newton was born back in 1642 and died in 1727. He's an Englishman, and Gottfried Wilhelm Leibniz was born in 1646 and died in 1716, was a German. They both invented calculus independently of one another in the 17th century. So I've been telling you over the last couple of weeks that we have two people that actually invented calculus separately by themselves. You can tell that they were born and died roughly around the same time. And so they both get credit from some people for creating calculus. Some people give one credit and the other one no credit. It just depends on who you ask. One of them published their information first in like a newspaper or a magazine kind of thing. They published it, and then one of them wrote about it to a friend, but it wasn't published. And so the one that published it after that letter was supposedly written, but by now most people give both of them credit for it. So I have a video that's going to play how you pronounce the second one's name. You can pronounce it a little bit differently, and so I'm just going to let that play for you.
Gottfried Wilhelm Leibniz. Gottfried Wilhelm Leibniz.
Gottfried Wilhelm Leibniz.
So I go with the Leibniz pronunciation, but if you want to go with the Leibniz, it's not really wrong. It is a foreign name, so whatever you pick is not really a big deal. All right, so Newton placed a dot over the y, and he wrote y and wrote y dot. That's where the y prime comes from. And then Leibniz designated the notation dy over dx. And so that's why we have two different notations. They are both useful depending on what you are doing. So don't try and pick one or the other to use, because both of them are used throughout calculus. So we're going to say y equals f of x, and it's a function that can be differentiated. So we're looking at what is the definition of a differential. So differentiated, differential, those are terms that are used not interchangeably, but they're different endings for the same type of word. So the differential of x is denoted as dx, and it can be any non-zero real number. The differential of y, denoted by dy, is given by dy equals f prime of x dx. And so we're looking back at this y equals f of x up here. Y equals f of x. The derivative of y, the derivative of x is, you have a 1 here. We would bring the 1 down in front, and then you would have x to the 1 minus 1, which is just 1x to the 0, which is 1. Well, the derivative of y works the same way. And so the derivative of y is 1, and we took the derivative with respect to y. So 1 dy, that's where the dy comes from. And then the derivative of our function is just f prime of x, and we took the derivative with respect to x because that's our variable. So that's how that works. So we're going to look at an example. We have a function y equals 3x to the negative 2, 2x squared plus 1. And we want to find dy. So that means take the differential. Take the derivative with respect to y. That's how derivative and differentials are related. All right, so the derivative of y is dy. The derivative of 3x to the negative 2, hopefully you're not still doing 3 times negative 2x to the negative 2 minus 1. Hopefully you're getting to where you're doing that all in your head so that you end up with negative 6, because that's what 3 times negative 2 is, and then x to the negative 3. That's what I want you to get to so that you're no longer having to write this out. If you're not there yet, keep working at it. Don't just jump to it just so you get it wrong, but start working towards going from here to there in your head. And then plus 2 times 2 is 4, and then that's going to be just x. And the derivative of 1 is 0. And then we took the derivative of these two terms with respect to x. And so that's your answer for dy. Negative 6x to the negative 3 plus 4x dx. Okay, so now we're going to find dy again. So on this one, derivative of y is dy. The derivative of sine, hopefully you remember that, is cosine. And the derivative of cosine, hopefully you remember it, is negative sine. Now our variable is not an x this time, it's a t. So we're going to do dt because we took the derivative with respect to t. So that's how those work. You just take the derivative and then you put a dx, dt, ds, dk, whatever variable you took with respect to the derivative. So that's how you do differentials. So your homework is 1 through 25 tonight. Make sure you do those so that we can go over any questions you have tomorrow.